So the first thing is to set this up to measure electrical current. Current is measured in amps or amperes. So to do that, what we're going to do is measure the current going through this resistor. This resistor here is labelled as 5 ohms. But now, to connect it up correctly, first of all, we can probably see that here it says 10A DC. So I've got the power pack here connected to the DC, the direct current, and what I'll have to do is where it says A for current or for amperes, I'll put that in here, and then the lead from that goes then to the what we call the COM port. So I've connected it there, and now I'll connect that round to our resistor and connect this resistor there, and I'll just turn the voltage up, and I need also to adjust the dial here so that it's going to go to 10 amps. Now we turn it up here to 10 amps because that's going to be the maximum. So it's around there now, and at this stage I've turned the ammeter on, but I haven't turned the power pack on. So when I turn the power pack on, you can see that what's running through our circuit here is a current of 1.38 amps. 1.38 amps or 1.38 coulombs per second. That's another measure, if you like, of electrical current. Now, one of the things that you need to notice here in the way in which this has been connected is that it's connected in series. Now, what does that mean? It means that the flow of electricity goes through each of these things one after another. Now you can see that this changes a little bit. So when you're making your measurement, it's up to you to make a judgment as to what the number here is. Now we're going to set this up as a voltmeter to measure the potential difference across a resistor. So because I'm using DC, I'll turn this to 20 over here. Now there's quite a number of numbers there, but I'm using 20 because 20 is the maximum potential difference that comes across our power pack here. So the first thing to do will be to connect the resistor in a circuit, in a series circuit, and that's going to be the only thing in the circuit at this stage. Now once you've got that connected like that, the next stage will be to turn our dial here so that it is sitting here on this 20 if need be, and then we can connect the multimeter in parallel with our resistor. Now this is the thing about voltmeters, they are connected in parallel. So once I've got that connected like this, and you can see the way in which that piggybacks on that, and this one here will piggyback on this one. Notice too that what I've done here is I've chosen a different port here where it's got V for volts. So that's how we connect this as a voltmeter. We connect it in parallel. Now, one of the reasons why we connect things, why a voltmeter is connected in parallel, is that we're measuring the potential difference. We don't want a large current running through the voltmeter. We don't want a large current. We want most of the current to be going through. So if that's the case, then we have a very, very high resistor or resistance operating when we connect it as a voltmeter. Now when we connected it as an ammeter, it was we used a different port, And what that meant there was that the resistance of the ammeter was very, very small. And the reason being that we wanted very, very little interruption of the flow of electric current as it operates as an ammeter. So now I'm in a position to turn this power pack on. And when I've done that, it's gone through a short circuit. So now I'm going to turn this back into a voltmeter and have those two connected there. Turn the power pack on, and you can see there that the measurement is round about 7.3, whatever we choose there, 7.3231. You just have to make a decision there as to what you think it is. Now, on the power pack here, it says 8. This is the accurate one. You take a measurement from this. Now, you might notice that there is a negative sign there. That's not a problem. If you don't like a negative sign there, all you have to do is swap the leads over, and the negative sign disappears. So that's how we use it as an ammeter or voltmeter. So our multimeter is quite a useful thing. We can also use it to measure resistance, and perhaps another video might do to cover that.